We're building rovers, we're building lunar systems, we're building construction systems with the intent of having rovers we can use on the moon, build on the moon, build out of materials we've got on the moon so that we don't have to ship all of the materials up there. For the larger scale projects, I'm working with Capstone and Senior Design Projects with Florida Space Grant. And all the software is written, the hardware is designed, the systems are put together and they're assembled. They're all done by the students. Capstone and Senior Design teams do the actual work. They design and build, they collaborate across the teams. Everything is student design. On the education side, it's what can we do to fill in gaps that students are missing. There's a lot of stuff that happened and is really kind of a recent development where things don't break. Kids don't have the idea, the concept of taking something apart. They don't have things they can go take apart. So there's assembly, working, building stuff, putting stuff together. We found that people my side of 40 have done a lot of that. People the other side of 40 from where I am have not. So we've got projects for folks to go put stuff together like that. We started out trying to take rovers like what's behind me and use those with undergraduates, freshmen. Their schedule was full. We started looking at high schools and ran into a teacher that said, my elementary school kids can go build this. So she is a 5th grade STEM teacher. We have 5th grade classes building these robots. The purple one back here was built by the 5th grade STEM class. It works as well as the other ones. It's the teachers created the lesson plan, or we provide them with drawings. We don't provide them with detailed instructions or a video or anything. They've got to figure it out from the drawings. And so 5th graders are figuring out transmissions, gearboxes, building the electronics, putting everything together. And it's the first time they've done anything like that. And they're absolutely awesome at it.
So I do a lot of the mechanical design that happens with these robots. And now most of the design came to us by other people who are also working on these, but sometimes a little change needs to be made or a part needs to be updated, and that usually falls onto me. I always enjoy working with students. They're every time smarter than you think they are, and really catch on really well and easily, and they love figuring stuff out. Generally speaking, it's a great time, and they're all really smart and fun to work with. All the software stuff is pretty much provided for them. This project hopefully will get to a point where we can have maybe not elementary school students, but other grade school students starting to do a little bit of software editing and changing for learning. But for the elementary school students that are doing it now, they're all doing assembly.
So with the software, there is an interface that the user has to interact with. Whether that can be a phone app, that can be a desktop app, or it could be any kind of application. You need to be able to have some kind of system where you can say, I want to move forward, I want to move backwards, I want to go left, right, or I want to speed up, or I want to slow down. This has been worked on by a lot of different teams, so it's been passed around a lot, and then there's a lot of work that's been built up over the years. And so if you're building everything from scratch, it would take you a long time. But what we do is like split tasks up into manageable sizes, so each week we have something to do. You get to see some of the groups of kids split up and work together on this project that if you were doing by yourself like me, it might take you a while, but for them, they're enjoying every step of the way and they're doing it much, much faster than at least I could by myself.
It's really fun. It's really rewarding because you can see all the kids and their mind working and watching them build, and maybe some of them aren't interested at the start, but by the end, they've kind of gotten like involved as they see the robot, becoming a real robot and actually able to move around. So it's really rewarding.
Being able to work with these robots that not only are setting up future engineers to develop stuff to work on the moon and setting them up for their future, but it's also directly developing technologies that will be useful on the moon.
Watching them learn is very, it's just, from my point of view, it's absolutely fantastic to go watch. There's a problem to go solve, they sit down, they go solve the problem. They work through the problem. You'll see we give them an exploded view, or an old style, just an expanded view of what the parts go like, and they'll be up there bringing the parts up, holding them up against the picture on the wall, and putting things together that way. They're mentored in how to use the tools installed by the students that we've got here. But the students of the elementary school kids are doing the work themselves, putting things together.